Hi everyone, my name is Dhruv Patel, and today I will be presenting Project 1 from the class of Design and Manufacturing taught by Professor Hassan Rashidi at Georgia Tech. And I will be going over 5 topics that I learned in class that I think are very, very important for not just me, but for any engineers to know. A brief overview of those topics are that they are designed for manufacturing and assembly, high-speed machining, casting and forging, lean manufacturing, and tribology. These are very diverse topics that will help you grow as an engineer and also can work in congruence when solving a design problem or even a manufacturing problem. So I think one of the most important concepts for any engineer who's designing is to design any product in terms of manufacturing and assembly. This concept is very important because it focuses on reducing time to market and total production costs through making it easier for manufacturers to produce, so basically production efficiency. This is done by reduction of parts, such as making a snap fit rather than putting a screw in certain scenarios. Standardizing components, so having the same screw specifications rather than different for each component or part. And finally, optimizing assembly, so making it easier for people to put it together, maybe by having like a locator hole or like a pin that indicates where to put the part. All these effects come together to reduce complexity in a part, which in turn helps speed of production. One of the biggest downfalls of this concept is that it puts the engineer in a situation where the engineer must pick if they want to spend more time on designing process rather than getting the product to market more quickly with less manufacturing defects so that they could have customer reviews and maybe change some views on it. I believe that all engineers should know about high-speed machining. This is a tool that can be used to create complex parts from spinning materials at very, very high speeds and meticulously cutting at calculated points. This way, there is less thermal damage to the part as opposed to, say, molding, because there is less minimal contact when cutting, and that also in turn reduces tolerances when making the part. Essentially, one of the biggest benefactors of high-speed machining is its capability of machining complex parts with incredible tight tolerances and precision. Although this seems like a very good manufacturing technique, it is extremely costly to invest in initially unless the company is sure that they will be producing hundreds of thousands, if not millions of parts, because these types of machines don't wear easily. And they also minimize turnaround time, which is less time needed to cool and harden the material because minimal heat is transferred when cutting. If you're looking at making a strong and long-lasting component, you should learn about casting and forging manufacturing methods. Casting is done by pouring a molten metal into already formed molds, molds which can be some sort of dye or even sand, and this allows for complexity in a part and easier removal process from cooling and hardening. Uh, on the other hand, in forging, metal is heated until it's malleable and is then deformed into the shape that is needed using immense mechanical force. These materials are highly durable, meaning long-lasting and can resist wear. They have great tensile strength, so they don't buckle or fracture. These processes are mainly used in aerospace industry and automotive industries due to their resulting properties such as longitudinal grain flow across metal surfaces, making it stronger and resistant to impact. While these methods are easy to use, they do have defects such as porosity, meaning gaps are formed in material due to air bubbles or other materials uh, that will be not accounted for, and this is a problem in casting. Forging does require a high force machines. It does require high force machines and are incredibly precise. Needs incredibly precise tooling to get the exact shape. Not to mention, it is very, very time consuming. All right, so lean manufacturing. This is a very deep topic, so I will just try to keep it short. But there are a lot of little nuances that you can learn from in this technique in manufacturing and even sometimes supply chain. So a lot of the times you'll run into a situation where you'll have to improve product profit margins, and many times it will be done through reducing cost of production. So this is where manufacturing comes in, and it is based on five principles that are listed here. Define value, so what are the customer wants and what do they need? How much are they willing to pay for it? Those kind of things. Mapping the value stream, uh, which is basically the customer wants and needs that are need to be defined. So what is excess that needs to be removed and what is necessary to be kept. Creating workflow, so finding a way to remove all that excess waste as a process and making it easier for manufacturing, such as reconfiguring production process or even lessening the workflow. Establish the pull system, so there isn't any excess inventory or even work in progress items, allowing for a smoother workflow and faster delivery times. And finally, pursue perfection, which are just the congruence of the last four steps, so that maximum waste is prevented. The biggest downside to this strategy is that it would take a while for new adopters to put into place the system if they already have one, and this would require a complete cultural shift and also continuous process improvement as things go on. Finally, tribology. So tribology is a very important topic that I personally think every engineer should know because it comes up in most professions. So when designing parts that are part of bigger assemblies, which is almost always the case, you will have to consider the surface roughness and the surface texture and how it impacts the product as well as other products around it. So what is tribology? Tribology is the study of rubbing surfaces, which includes friction, wear, and lubrication. Understanding tribology is crucial for minimizing energy loss and reducing equipment wear. This is done through lubricating surfaces with substances that allow easier sliding of two materials, so this eliminates most of the friction, and in turn this also reduces wear. Limitations on this concept is that it is mainly used in niche applications such as when you don't want something to slide, for example, brakes in cars. When you brake in car, you don't want the wheel to slide, or when you want something to move smoothly, like axles in cars, so there's no friction in between those points. Uh, these coatings are very important in these applications, and they're extremely expensive. And the surface applied to requires a lot of attention and treatment as well as care throughout its lifetime. That's why you also have oil changes in cars. Uh, Alright, and these are my sources. I only have five sources and information mostly from class lectures. So if you want further elaboration on these topics, then feel free to go ahead. I thank you for listening and learning with me. This I hope that you have learned something from this video and hope that we could agree on some topics that are very important for most people in their careers. Thank you again. Bye bye.